So yes, this is me, Michael Cowling. Those biographies always sound a bit weird when you hear them yourself, don't they? I think next time I'm going to write a funny one. You know? I've heard a couple of funny ones this time. So yeah, I'm going to talk to you a little bit about humanoid robotic teaching assistant and the project that we're doing with a robot to help in the classroom. I've given it an alternate title though, and my alternate title is A Short Introduction to Boris the Teaching Assistant, because that's his name. And the funny thing is when you're working with anthropomorphic robots, you very quickly give them a name and a personality, and you tend to refer to them by their name. So if you hear me say Boris does this and Boris does that during this presentation, that's why Boris is our robotic teaching assistant. Or the alternative title, the third title, is How Can a Robot Help Me in Class? And hopefully that we can give you some ideas. If you're from IT infrastructure or the IT department at a university, maybe this helps you think about how you can use robots in classes at your university. If you're an academic, maybe it helps you think about how you can use them in your own particular class. But before I get into talking to you about the robot, first of all I'm going to talk to you a little bit about me. And this is a slide that I often use to describe myself. So the picture there in the middle you've probably seen. That's the image of me in the program. And then there's two other representative pictures. The one on the right-hand side is me from late last year getting the National Teaching Award that was mentioned in the biography. And I put the picture up there not to brag, but to tell you that I am a teacher. That's what I've done for a long time, quite a number of years. I teach in the classroom, I stand up in front of the students and deliver lectures and tutorials and teach students. And I quite enjoy doing that, and so that's why I'm interested in this process of helping to make classrooms function more effectively. And my research focuses on that, including the robotics project that I'm going to talk to you about today, as well as work that we do in mixed reality. And you've probably heard some presentations over the last couple of days about mixed reality or augmented reality or virtual reality. I think some of our keynote speakers even spoke about some of those ideas. And that image on the left-hand side is an image that my university generated that is an example of the kind of work that I do. Now, it's a marketing image. I can't actually do that. I wish I could hold my hands in front of me and have holograms appear. It doesn't actually work that way. But it gives you an idea of what we do when we do research in mixed reality, which is combine the physical and the digital together. Again, the focus for me is about improving classroom practice by doing that. And here at this conference they actually have a couple of HoloLenses, so in actual fact if you want to go and put on a HoloLens, and maybe I could actually do that for you, you could see the holograms, but you'd need to wear the headset. I run a research lab called the CREATE Lab. CREATE stands for Collaborative Research and Engagement around Education and around Technology and Education. It's coming soon. It's one of those web pages that I'm forever building. But if you're interested in knowing some of the other stuff that I do, you can go to my website, which is www.michealacowling.com, and you can get a bit of an idea of some of the work that I do, including some updates on the robotics project that I'm going to tell you about. The other thing that I do is I advocate for technology in the classroom. And as I tell you about the robotics project, I want you to remember this approach that I have to technology in the classroom, which is that technology should just be part of the class. And I'm really overjoyed to hear various presenters say that over the last couple of days. They're saying things like technology is not useful for technology's sake. Technology must serve a purpose. I've also heard people say that they have trouble with their IT staff sometimes in that regard because we're IT people. I'm an IT person and we think technology is cool. And so we want to try the technology out, but my argument is we need to make sure that it actually serves that purpose. And so I advocate for that in all of the work that I do. If I were to summarise, then I would say that the idea is that we should have pedagogy before technology. And that's the mantra that I've started using in the last couple of years. And I was really excited over the last couple of days. I ran into another participant in an elevator, actually. And I was talking to him, and he was in IT infrastructure, but he said exactly the same thing to me about infrastructure. He said, look, I have staff that think technology is wonderful, roll a piece of technology in and then say, what are we going to use it for? And I said to him, wow, we have exactly the same problem with IT staff in the classroom, right? You need to go the other way around. You need to say, what's the pedagogical problem that you have, and then how can technology possibly solve that problem? So, in other words, start with the problem in the classroom, then think about ways to solve that problem, and then work out how technology can help. And the interesting thing is, if I'm an educational technologist, but if technology can't help a particular problem, then don't use technology. If a problem you have in the classroom is best solved by dressing up in a clown outfit and delivering your lecture as a clown, do that. Right? So we don't need to use technology. And a term that I saw somebody use in this conference, which I'm going to shamelessly steal, I think, is real reality. We could have mixed reality, virtual reality, augmented reality, and then real reality. Sometimes real reality is the best reality. And that's coming from me as a technology guy, as a technology apologist, right? I love technology. So with that in mind, I mean, I would hope that there are situations where technology makes sense. You know, maybe we can dress the robot up in the clown costume and he can do the lecture, right? And that works better for you. And if that works better, that's great. That gives me something to do as an educational technologist, and hopefully it improves the pedagogy in the classroom as well. So anyway, with all of that sort of background, let me tell you a little bit about the project that we've been working on in robotics. And this gives me an opportunity to show you a picture of Boris, who's there on the right-hand side wearing our CQ University research hat. It doesn't fit him very well. We need to get smaller clothes made for the robots. But basically, I got the opportunity to use Boris through an industry partner. And we thought, well, there's an opportunity here to use him for, in this particular case, robotic teaching assistance. But in order to do that, we needed to make some interesting technological changes, because robotics is a relatively new field, especially in education. And so we needed to start thinking about how can we actually work this robot into the classroom. And in particular, one of the things that we needed to think about is, where do the brains of the system actually sit? Do they sit inside the robot, or do they sit somewhere else? And that's when you start to venture into this area of robotics architecture in the cloud, where you start to say, well, how much of what we do needs to be focused on the robot? How much of what we can do can be an Amazon Web Services instance out there in the cloud? And the answer, of course, is that not that much that we do needs to be in the robot. And I think this is interesting. I think a lot of people conflate together robotics and artificial intelligence. They expect that the robot has to do all of the thinking. But of course, we're in a cloud, net-connected society, right? So the robot doesn't have to do all of the thinking. The robot can just be an interface. You can talk to the robot. The data that you provide to the robot can be sent to the cloud for processing, and then that data can come back to the robot and he can speak it. So then we're using the robot because the robot is a better way to engage with the audience, particularly, for instance, if we're talking about students, and particularly younger students, but we don't need to have the brains of the system in the robot. And we saw that today in the keynote speech a little bit earlier with Micheal. She showed us an example of a virtual avatar that was driven by IBM Watson, which is a very advanced artificial intelligence system that IBM has developed. So it did the thinking, and the virtual interface just gave you the person to talk to. So our industry partner, my industry partner, was really interested in this. They said, oh, you know, look, this is a really interesting project for us, because we get the opportunity to experiment with how we're going to build a robotics architecture in the cloud, the things that we'll do in the cloud versus the things that we'll do on the robot, and how that all kind of works together. But of course, for me, it's pedagogy before technology, right? So before we did this, I needed to say, well, is there a problem? And luckily, as I said to you, I'm a teacher, so I know that teaching assistants are useful, and that having some help in the classroom can be useful, not just for programming or robotics stuff, but just for general help in the classroom. And I actually went to the States last year, and they use teaching assistants a lot in the classroom. The professor has the teaching assistant come along to every class, listen into the things that the professor says, and they're also available to talk to the students and field questions for the students and things like that. And often that's helpful because often the students don't want to talk to the professor. They're concerned about looking stupid in front of the professor, so they prefer to talk to the teaching assistant who feels more like a peer. And so that's where we started, this idea of a problem, right? The fact that teachers are short of time and that students sometimes worry about asking a teacher questions or interrupting the class. And so we thought, how can we help with that mechanism? How can we give the students the confidence to ask the professor a question either in class or give them a mechanism to ask questions about the class outside of class without talking to the professor? And this is based on some work that I did a couple of years ago using Twitter as a mechanism to give students extra feedback. So in that work, students were able to use a mobile device to send a tweet, and the tweet would appear on the slides, and the academic or the teacher, the professor would have the opportunity to see those tweets, which were anonymous, and incorporate the answers to those questions into their class, into their lecture. It was all good, but of course it was using Twitter, it was all public, and even though the students were anonymous, they were concerned about putting these questions out on a public forum. So it worked okay. But so we could do the similar kind of thing, but we could do it with the robot, and that helps us to give the students a chance to ask those questions anonymously. A couple of years ago when I did do it with Twitter, somebody did accuse me of cotton wooling the students. And I mean, that is potentially a concern. You're just trying to cover for the students. But I think even if you think you're cotton wooling the students, well, let's do that to begin with. Let's use it as an icebreaker, and then the students can interact more a little bit later. And I'm sure we've all heard the old adage about there being no stupid questions, right? You know, so the robot asks the question and everybody else gets the benefit of the answer. But as well as that, we have the opportunity for the students to feel more comfortable in class as they go along. So we put forward this idea of the student working as a the robot working as a teaching assistant. And of course, the advantage of the robot over some other teaching assistant is that he can be a little bit more of an expert in the field. Often teaching assistants at primary schools and high schools are volunteers or parents. At universities, as I said to you, they're often PhD students or graduate students. So I suppose they're experts, but they're probably not as expert as the professor. So our robot gives us an opportunity to provide students with a familiar humanoid system to interact with, but without those concerns of looking stupid. So I wanted to support this with some research work, and so I went out there and I said, well, what do teaching assistants do? You know, when you ask people what are the benefits of teaching assistants, why do we have a teaching assistant in the classroom? Are these the kinds of things that they're interested in teaching assistants doing? And will the robot be able to do those things? So I went and had a look at some research, and there isn't much research about teaching assistants in higher education, but I did find some work about teaching teacher aides in primary and secondary schools. And so here's the top 4 things that we expect teacher aides to be able to do in primary and secondary schools based on a survey from 2015. The first one is working with small groups of students on academic tasks like reading, maths or science, etc. That's 100% of the sample said that was something that teachers' aides should do. General classroom support for students and teachers is also 100%. Administrative duties for teachers like photocopying, data entry, filing, etc., 96%. And then one-on-one support for ascertained students with disabilities was 67%. So I looked at that list after I pulled that data, and I thought to myself, okay, I can get a robot to do most of those things. I can't get a robot to do the photocopying and the filing yet. That's a little bit challenging for good old Boris. He's only about 2 feet tall. But I can definitely get robots to do some of the other stuff, to work with the groups, to provide the general classroom support, and also, and I think this is the most interesting, provide that one-on-one support, not just for students with disabilities, but also for any student that has a question that they want to ask. Imagine the idea of giving the robot office hours. People can go and talk to him. So we decided to build a system, as I said to you, and the robot that we decided to use is a Now robot. And you've already seen a picture of him. He's produced by Aldebaran Robotics. He's around about 2 feet tall. He has 2 cameras, a top camera and a bottom camera. Don't ask me why they're top and bottom. as a mixed reality researcher. I'd much rather them be side to side, but they're not. He also has a couple of microphones, a left microphone and a right microphone. I actually think he has more than two microphones, but when we think about it, we tend to think about one in his left and one in his right ear. He also has basic voice recognition, and importantly, he has full articulation. So he can move his hands, he can move his feet, he can sit down, he can lay down, he can move around, and you interact with him like you interact with a person. As I said to you, the Now robot has enough personality that you start to refer to him, as I'm doing, as you're listening to me, in the first person. Right, so and I think a lot of that has to do with the anthropomorphism, the fact that it looks like a very, very small person. In terms of coding, you're programming using either a graphical tool called Choreograph, or if you want to be more technical, you can use Python to code him as well. And in fact, most of the stuff that I'm going to tell you about today was coded using Choreograph. Some of the work that our research assistant is doing now, he's moved on to using Python because he gets a little bit more flexibility. So this is what Choreograph looks like, and you can see on the right-hand side our virtual robot. So you don't actually need to have a Now robot to write stuff in Choreograph. You just basically connect all of the blocks together, and then you can provide a behavior to the robot, and then you can see what the virtual robot does. Of course, it's infinitely cooler if you actually have the robot and you can see the real robot do the task, but that's what Choreograph looks like. So we got access to a Now robot, as I said to you, through an industry partnership with a company called Acme Robotics based on the Gold Coast. They had a Now robot already, which they said, yes, you can use this for some of your teaching assistant trials. As I said to you, his name is Boris, and we decided to do various different things with the robot, initially based, as I said to you, on that Twitter project that I was telling you about a little bit earlier. So the robot has the opportunity to collect feedback from students, and the students are able to say, look, I have this question, can the robot ask this question for me? And then has the opportunity to pose those questions to the instructor. And he does it by sitting in the classroom, and when he gets a question from the students, he raises his hand to let the academic know that they have a question, and he'll usually tell you, well, he will tell you the amount of questions he has. So he goes 1, and then if there's another one, he says 2, etc., etc. And when the academic is ready to field those questions, he or she walks over, touches the robot on the head, and the robot then provides the questions back. We then record the answer that the academic provides, and we're then able to provide those answers back to students later on. So as I said to you, imagine the robot having consult hours and the students being able to go to the robot and say, do you have anything about database normalization? And the robot says, yes, in fact I do. Here's a question that somebody asked a couple of weeks ago, and provides the answer as said by the lecturer. And recently we've actually added a function where the academic can also add those questions to a knowledge base as well. So it doesn't have to be something they answered in class. Maybe they know that students always struggle with database normalization, so ahead of time they write an answer that can be delivered by the robot. So they write it in text, and then the robot delivers it for them. We also have a mechanism for the students for the robot to deliver a lecture, if that's the kind of thing you want him to do. And we also have a mechanism that we added just recently, actually, for the robot to deliver a pop quiz. And that actually works pretty well, and it's kind of cool. You know, the robot stands up the front, asks the question, the students answer the question on their device. The robot will then tell them that their time is up. We'll say how many students got the question right, how many students got the question wrong, why they got the question right or wrong, so a rationale for the correct answer. And then at the end of the session, it keeps track for each individual student, and the robot tells you how the class went, and then the student gets told that they got 2 out of 5 right, or 3 out of 5 right. So we built that system, and I'm going to tell you a little bit in a second about how that system works, and the various different components that make up that cloud-based system. So the first part of that system is a robotics assistant instruction set that we actually built for the robot. And the idea behind this was that we wanted some flexibility, so that if we decided we didn't want to use a Now robot in the future, then we could swap out the Now robot for something else relatively easily. And so we wanted a standard set of instructions that you could send to the robot to get him to do various different things. And so then another piece of technology should be able to be written, coded to easily adopt that instruction set as well. So here's some examples of some of the things that we get the robot to do. You can see that we have the opportunity to set a timer on the robot. We have an opportunity to get the robot to speak something when the lecturer interacts with him. We also have the opportunity for him to speak now. And then we also have some commands for moving, which we don't really use very much. We have also an opportunity for collecting student responses as well about how they work with the lecture. We don't really use that one very much either. It was an idea we came up with that we haven't really used. And then we combine those together in order to get the functionality that I was telling you about earlier, the opportunity for the robot to interact with the lecturer and deliver questions and ask questions on behalf of the student and things like that. So that's the first step. We have the robotics assistant instruction set. Inside of the robot, that's actually pretty simple because it's a pretty easy thing to sort of interpret. So this is the entire choreographed program for interpreting that instruction set. So there's three modules: do timer, do process, and do action. And those modules then interpret those instructions and then turn them into commands that actually make the robot do things like raise his arm and speak and et cetera, et cetera, et cetera. And if you want to know a little bit more about what's inside each of those processes, then you can go and have a look at the paper, and that paper will give you a little bit more detail about how that actually works. So that's our first component. That's what happens on the robot. And then the second component is what happens in the cloud. So then we have a server-side system which is implemented using PHP that allows us to actually get the robot to do things. And it generates that instruction set. So here's the code that actually does that for a simple command where you actually want to get the robot to speak a question or keep track of a question that has been sent by the student. So I won't read through the code. It's basically pseudocode for that mechanism. But the key point I want to make is that we've broken things up, right? What we've tried to do is we've tried to say the robot is predominantly an interface and the thinking is actually going to happen in the cloud. And so we combine those two things together, and what that should allow us to do is swap out the robot if we want to, add other components to the system in the future. So we've got this more flexible cloud robotics infrastructure. We then brought it all together, so we've done some usability testing of this implementation, and you can see here the robot on the left-hand side in the classroom with the lecturer there looking a little bit pensive, I think, about the robot doing some collecting the questions. This was just for the picture. Then we moved him off to the side where he collected the questions. And on the right-hand side, you can see the interface that the students use to actually ask the questions. So you can see a list of the previous questions down the bottom, and you can see the opportunity they get up the top to type their question in, press the ask button, and then the robot will take that question and ask it on their behalf. So we're going to conduct some more research with this. We're using a design-based research methodology. So at this point, we've done our initial data gathering, we've done our initial prototyping, and as I said to you, we've added some new features based on that, the quiz functionality, the Q&A functionality where the lecturer can write the answers ahead of time. And eventually what we're going to do is we're going to hopefully do some classroom testing using the teaching acceptance model, the technology acceptance model, and do some pre and post testing for learning outcomes as well. And then we'll do some more data analysis, we'll do some more prototype refinement, the way that DBR works, and loop through to build a system that really works well. So the last thing I'm going to do, I'm conscious that I'm almost out of time, so the last thing I'm going to do is I'm going to show you a little bit of a video of Boris in action. So there's a picture of me posing with Boris. I think he's more photogenic than I am. So what I'm going to do is I'll show you a little bit of him. This is his introduction to the class. This is what he says to the students when you bring him into the classroom for the first time, and give you a bit of an idea of what he looks like and the kinds of things he says. I would have loved to have brought him along, but he doesn't like plane trips. So let's see how that goes.
If you need me as a teacher assistant, please say teacher assistant or press my forehead button. If you need me as a lecturer, please say lecturer or press my top rear button. If you want me to introduce myself, please say introduce yourself or press my top middle button. Or if you do not need my help, say exit or touch the front of my feet at any time.
Introduce yourself.
Hello everyone. Please let me introduce myself. My name is Boris. I am a Now robot, the first humanoid robot of the Aldebaran company. I am the smallest member of my family. Other members of my family are Pepper and Romeo. Pepper is a companion robot who can perceive emotions, and Romeo has been designed to help elderly people, or people losing their autonomy. The first Now model came out 10 years ago, and now we are in our 5th version. Some of my strengths are my interactivity and personalizable interface. Thanks to these strengths, other Now robots have participated in television shows like Robots where 7 Now were on stage. Others in robotic sport events or even as receptionists. Currently I am working with Micheal Cowling in Acme Robotics exploring how I can help in a classroom.
That probably gives you an idea of how he works. We worked on that since then. We did some tweaks. You notice the beeping behind the scenes? That's because he keeps on trying to listen for what people are saying. We took that out. We've also refined his speech to make him a little bit easier to understand. But that gives you an idea of how he works. That's about it for me. Hopefully that helps you understand how it works. Don't forget pedagogy before technology. And if you want to know more about what I do, then www.michealacowling.com. Thank you.
So we have some time for some questions, if anyone would like to take this opportunity. Yes.
Yes, you could. That's a very interesting question. Our experience has been that interacting, even we do it, interacting with something that's anthropomorphic, that has 2 arms and 2 legs, really helps the students to feel comfortable and to interact with him. I think if we were to say the students go to this room that has a video kiosk and talk to an artificial intelligence, I'm not sure that would be as successful as actually going to talk to Boris. So that's our idea. Now, having said that, we may work through the project. We might decide that an artificial intelligence works just as well. But for now, the anthropomorphization is the big deal. And Aldebaran, who market the robot, that's what they push when they try and sell the robot.
Any more?
Sorry, there's one over here.
Just one over there, Michael.
I thought you were going to ask me about when the robots were going to steal my job, or our jobs, yeah. And I was going to say we always make the word assistant in capital letters for that reason. Right. No, that's a very good question. Look, I'd be interested. Look, I'm happy to comment on that. People ask me that sometimes as an educational technologist. Well, eventually aren't robots going to steal all of our jobs? And I think my argument is always, yeah, they probably are going to steal some jobs, but then there are going to be other jobs that we have to do instead. And so I think there's always going to be those kinds of positions. But yeah, I could definitely see. Boris is a small robot produced by Aldebaran, but they're talking about producing a robot called Romeo, which I think was originally due for 2018, which is about 4 foot tall. So that robot can actually walk around your house and do various things on your behalf. He can go and get your pills for you so that you don't have to get up out of bed, fetch the remote control. So yeah, we should fear our robotic overlords is basically what I'm saying.
Any other questions? Sorry, it's just a bit hard to see. No? Okay. If there's no further questions, can you please join me in thanking Micheal? Well done.